So, yes, again, most people got it. Some people don't know how to do it. Let me see your hands. They want me to do it. What do we have? We have two solutions, right? Actually, we don't have two solutions. But let's say we have a solution which is, you see, it's big difference. We have one solution, and in that solution we have 0.20 molarity potassium carbonate. That means 0.2 moles per liter. And also it's 0.2 moles per liter of sodium chloride. So this is the concentration of each salt. So many moles per liter. So if you consider 1 liter, in that liter you have this number of moles of this salt and this number of moles of that salt, correct? Okay, so we say we have 0.20 moles per liter of sodium chloride. And because when you have sodium chloride and dissociates in water, it gives you 1 cation and 1 anion, right? One formula unit will give you 1 cation and 1 anion. Therefore, if you want concentration of cations, then you will say if 1 formula unit, that means 1 mole, 1 formula unit gives you 1 ion and 1 ion. Ratio of particles or units is also a ratio of moles. Hope you understand why. Therefore, 1 mole of this will give you 1 mole of this and 1 mole of that, correct? If you have 0.2 moles of this, how many moles of this you will get? 0.2. Well, therefore, we have 0.20 moles per liter sodium plus. You understand this? Yes? Okay. Now we'll go to the next. We have 0.20 m of potassium carbonate. What will be the concentration of potassium plus in this case? Huh? How much it will be? Now we have potassium carbonate, and that one dissociates and gives you how many cations? 2. So from 1 you get 2. So from 0.2, how many are you going to get? 0.4. Okay, so you will have 0.40 moles per liter of cation. What do you want? Cation, not an ion. So how much is it going to have? You have so many moles per liter of this, so many moles per liter of that, per liter. For the same liter, right? Same solution. So the concentration of the cation will be cations. That would be the answer, right? Now here's the question. So we don't memorize things like parrots. No. Like parrots, right? We don't want to do it that way. Okay. So let's say that instead of telling you we have a solution with these two things, this concentration, let's say that we have the same salt, same concentration, but we have one solution here, 1 liter of 0.2 m sodium chloride, and you have another solution here of volume of 1 liter again, that is 0.2 m potassium carbonate. And you mix them. How much will be the concentration of, total concentration of all cations now? What's the number? Don't say it loud. Let us think. How much will be the answer? What the number will be the answer? What's the answer? 0.3, correct. How many people want to understand that? Let me see your hands. At the end. Oh, it's really easy. Good. Instead of having 1 liter, we have the same number of moles per liter for each, right? Same concentration. Instead considering these moles in 1 liter, both types of salts in 1 liter, now you have these moles per liter, and you mix them to make a new solution. That solution is going to be now what volume? 2 liters. So the same number of moles now, they're not going to be in 1 liter, it will be 2 liters. The concentration is going to be half. It was 0.6, it's going to be 0.3. Right? You see, before was both salts with these concentrations are in one solution. So you consider 1 liter, you have this concentration moles and this number of moles. Now, the same number of moles for each salt, they're not going to be in 1 liter, because you mix 1 liter and 1 liter, it will be in 2 liters. So the same number of moles now are in double volume. If you double the volume, the concentration goes half. So the answer should be 0.3 in this case, right? All right, let's see. Let's see, maybe we should get the break now, or let's see what time it is. Let's take a break. 10 minutes. And I want you to stay there and, well, I'm not going to go to the bathroom, because this is going to be good for you. Okay? You can go to the bathroom. For the first 3 minutes, it's going to be a nice song. I'm going to play the drum for you. But then after 3 minutes, you're going to see 6 minutes, 2 very short pictures of 3 minutes each. And then we're going to do the rest of the program, okay?
Far
did not follow the opinions of the beauty magazines. Because if he had followed the opinion of the beauty magazines, the way his body was so big, he would probably have committed suicide. But he didn't give any attention to what the world thinks is beautiful. He looked within. And he became a legend, a legendary man in Hawaii. When he died, the flag of the Hawaiian nation put the flag down. Only 3 people in Hawaiian nation history, the flag went down, halfway when they died. And one of them was Isaac. Why? He didn't even finish high school. Never went to college. He discovered the power, the beauty, the love inside him. And if you say, but I don't feel like Dr. Toupadakis like you do, and I don't feel like he does, then here is a recipe. Follow the words of these 2 people that you will hear now. One of them is a professor. He introduced himself. And the other one is someone that you have his ingenuity and his imagination, his beauty, you have it in your hands. Yeah, most of you have an iPhone, that came from which one? Someone who says, well, let's hear what he said. Right? Let's hear what he said. 3 minutes. And then 3 minutes with the other professor. And this is the way to gain the strength and the joy of life. Listen to them. If you don't want to listen to your teacher or chemistry teacher, listen at least to these people. Okay? So let's go for it. There you go.
What you love. You've got to find what you love. Got to find what you love. You've got to find what you love. I had no idea what I wanted to do with my life, and no idea how college was going to help me figure it out. And here I was, spending all the money my parents had saved their entire life. You have to trust in something, your gut, destiny, life, karma, whatever. Because believing that the dots will connect down the road will give you the confidence to follow your heart, even when it leads you off the well-worn path. And that will make all the difference. My second story is about love and loss. I found what I loved to do, and then I got fired. I really didn't know what to do for a few months, but something slowly began to dawn on me. I still loved what I did. The turn of events at Apple had not changed that one bit. I'd been rejected, but I was still in love. And so I decided to start over. I didn't see it then, but it turned out that getting fired from Apple was the best thing that could have ever happened to me. The heaviness of being successful was replaced by the lightness of being a beginner again, less sure about everything. It freed me to enter one of the most creative periods in my life. Sometimes life's going to hit you in the head with a brick. Don't lose faith. I'm convinced that the only thing that kept me going was that I loved what I did. You've got to find what you love. Your work is going to fill a large part of your life, and the only way to be truly satisfied is to do what you believe is great work. And the only way to do great work is to love what you do. And the only way to do great work is to love what you do. If you haven't found it yet, keep looking, and don't settle. As with all matters of the heart, you'll know when you find it. And like any great relationship, it just gets better and better as the years roll on. So keep looking. Don't settle. My third story is about death. For the past 33 years, I've looked in the mirror every morning and asked myself, if today were the last day of my life, would I want to do what I am about to do today? And whenever the answer has been no for too many days in a row, I know I need to change something. Remembering that I'll be dead soon is the most important tool I've ever encountered to help me make the big choices in life. Because almost everything, all external expectations, all pride, all fear of embarrassment or failure, these things just fall away in the face of death, leaving only what is truly important. Remembering that you are going to die is the best way I know to avoid the trap of thinking you have something to lose. You are already naked. There is no reason not to follow your heart. No one wants to die. Even people who want to go to heaven don't want to die to get there. Sorry to be so dramatic, but it's quite true. Your time is limited, so don't waste it living someone else's life. Don't be trapped by dogma, which is living with the results of other people's thinking. Don't let the noise of others' opinions drown out your own inner voice. And most important, have the courage to follow your heart and intuition. They somehow already know what you truly want to become. Everything else is secondary. I've always wished that for myself. And now, as you graduate to begin anew, I wish that for you. Stay hungry, stay foolish. Stay hungry, stay foolish. Thank you all very much.
What do you desire? What makes you itch? What sort of a situation would you like? Let's suppose...
So say, stay hungry, loud. Stay hungry, stay foolish. What does that mean? We can talk about it in the future if you want to discuss about it. What it means to stay hungry, stay foolish. If you think he was successful, then you should be interested to discuss this. So now, let's hear 3 minutes. Some other gentleman who used to be, probably he's still, I don't know the details, if he's still a professor, but he was a professor, he is a professor. And let's hear him.
What makes you itch? What sort of a situation would you like? Let's suppose, I do this often in vocational guidance of students. They come to me and say, well, we're getting out of college and we have the faintest idea what we want to do. So I always ask the question, what would you like to do if money were no object? How would you really enjoy spending your life? Well, it's so amazing. As a result of our kind of educational system, crowds of students say, well, we'd like to be painters, we'd like to be poets, we'd like to be writers, but as everybody knows, we can't earn any money that way. Or another person says, well, I'd like to live an out-of-doors life and ride horses. I say, do you want to teach in a riding school? Let's go through with it. What do you want to do? When we finally got down to something which the individual says he really wants to do, I will say to him, you do that, and forget the money. Because if you say that getting the money is the most important thing, you will spend your life completely wasting your time. You'll be doing things you don't like doing in order to go on living, that is, to go on doing things you don't like doing, which is stupid. Better to have a short life that is full of what you like doing than a long life spent in a miserable way. And after all, if you do really like what you're doing, it doesn't matter what it is, you can eventually you can eventually become a master of it. The only way to become a master of something is to be really good at it. And then you'll be able to get a good fee for whatever it is. So don't worry too much. Somebody's interested in everything. And anything you can be interested in, you'll find others will. But it's absolutely stupid to spend your time doing things you don't like in order to go on spending things you don't like, doing things you don't like, and to teach your children to follow the same track. See, what we're doing is we're bringing up children, educating, to live the same sort of lives we're living, in order that they may justify themselves and find satisfaction in life by bringing up their children, to bring up their children to do the same thing, so it's all wretched no vomit. It never gets there. And so, therefore, it's so important to consider this question, what do I desire?
absolutely. It is absolutely. Do you remember? Say it. It is absolutely stupid. It is absolutely stupid. Say, it is absolutely stupid. The teacher called his students. Come. No, we're going to fall. It's a cliff. We're going to fall. The teacher called them again. Come. They again said, if we do, we will fall. The teacher did not give up. He called them again. Come. And they came, and they flew. What would you do? All right, let's go back to our equations. So let's see this problem. Try it for a couple of minutes. 2 or 3 minutes, try it. You can do, the best thing you can do is try to put the numbers down, the symbols, the equations. And then by looking at these things, you don't need to look at the problem anymore. That is the way to solve problems. Prepare your own numbers, symbols, and equations. And then you put your hand on the top of the problem and you say, I don't need the problem. That means you understand what the problem is giving you, what it's asking you. If you cannot hide the problem and look only at the things that you have written down, then you mean you are not ready yet to solve the problem, to start solving the problem. Okay? So follow that advice because it's really very powerful to solve problems. Whatever problems they are, even in life, it doesn't have to be a chemistry problem. What you have in your hands and what you are asked for. The lazy bones probably will come tonight, but they will miss the best part of the lecture. Or perhaps they will show up. Who knows? We will see. We do our job, and they do their own. Good for you that you came in the morning. Really? Okay, I'm going to try. Beautiful. You want to find the relationship between molecules, and the ratio of molecules to moles, particles to moles is the same, right? So the problem is asking about relations between molecules. The ratio of molecules related to the ratio of moles. It talks about pressures, but the pressures relate to number of moles through the mole fraction. So there is a relation between pressures, mole fraction to moles, and moles to number of particles. So you can see the relation between pressure and number of molecules. You see? And recall the equation that you use that relates pressures with mole fraction. Let's try to do it without hitting the light. Okay, did you find any answer yet? What did you find? Eh? How many? A? So let's see how we do it, right? First of all, it talks about C. Isn't that right? It talks about C. So we're interested about C. That means we're interested about the pressure of C, the number of moles of C, because we talk about molecules of C. So immediately we see the problem is giving us A, B, total, but it doesn't talk about C. So the first thing that comes to mind is, can I calculate the pressure of C from the other ones? Because, why not? If you know the total is PA plus PB plus PC, you know everything else is PC, you find the partial pressure of the C. And then you think, okay, the partial pressure relates to mole fraction, the mole fraction to moles, the moles to molecules, man, that looks like the way to go, yes? So, we know that the P total is equal to the sum of the partial pressures of the three gases. And you know this, and you know that, and you know that, so you can take this. So if you solve for PC, minus P A minus PB, right? If you put the values, PC comes out to be 1 atmosphere. This is 1 atmosphere. We want to go from the pressure we know now to number of molecules. And the partial pressure relates to mole fraction, but the mole fraction relates to number of moles, and the number of moles to number of particles. So, PC relates to number of molecules of C through what? The mole fraction. You know any equation that relates the partial pressure with mole fraction. That's the definition of partial pressure in a mathematical way. Is the mole fraction of C times the total pressure. Isn't that right? And we know both this and that, so I can find out the mole fraction of C. So mole fraction is what? 1/4. Now, some people will say, why don't you make it 0.25? I'm not going to make it 0.25. And the reason is, I want how many molecules of C per 400 molecules of the mixture. So I want a ratio. So I don't want to make it 0.25. You see why? Just leave it there. That's why the thing, right? I want for ratio. I don't want to go into one number. Okay? So there's no reason to go into 0.25. That will be the wrong way to do it. Now, what is the definition of a mole fraction? It is the number of moles of that gas divided by moles of mixture. Isn't that right? That means total number of moles, right? And the number of moles, the ratio of moles or whatever, cars, lemons, drinks, electrons, bonds, the ratio of moles is also the ratio of entireties, particles, whatever it is. So it's going to be molecules of C per molecules of mixture. Yes? And that is, we know